Hey class, welcome back. We're going to begin chapter 7 today. Chapter 7 is all about gases, liquids, and solids. So we'll start out with just a brief introduction to the chapter, and then we'll start going through the chapter section by section. So in chapter 7, these are all of the things we're going to talk about and the corresponding text book section numbers 1 through 13. So it's a little bit of a bigger chapter, but you'll see a lot of the sections are quite short, especially at the beginning. So there's kind of the first half of chapter 7, which I'll post all of the lectures for the first half of chapter 7 in one kind of installment. And then I'll do the second half on our next lecture period as the second installment. So we're going to talk about kinetic molecular theory. This is kind of describing how the motion of individual molecules or atoms corresponds to the physical state of that substance. So whether something's a solid or liquid or a gas, we can determine that by talking about how the molecules are moving on an individual level. And that's kinetic molecular theory. So we'll start out chapter 7 with that. And then we're going to go into talking about what are called the gas laws. And these are mathematical relationships that we use to determine the volume, the pressure, the amount, the temperature of a gas. And so these are called the gas laws. We're going to cover 4 simple gas laws, Boyle's law, Charles's law, and Avogadro's law. And Avogadro's is not in your textbook, but it ties directly into everything else that's in your textbook. So we're going to cover it because I feel like it kind of leaves a little bit of a hole in your book if you don't cover it. And then we're going to talk about the combined gas law and the ideal gas law. That's kind of the first half of chapter 7. In the second half, we're going to talk about Dalton's law of partial pressures, which ties directly into the gas laws. So the only reason I put it in the second half is because otherwise the first series of lectures gets to be a little bit on the long side. So I know when we're in person and we have 2-hour and 15-minute lectures twice a week, we usually end the first lecture on chapter 7, the first 2-hour and 15-minute lecture at the end of section 7. So I'll post section 8 in the second part. It's on gas laws again, and this is Dalton's law of partial pressures. And then starting in section 9, section 7.9 changes of state, we kind of transition to talking about, okay, we've talked about kinetic molecular theory and the physical states of substances and all the gas laws, how to quantitate the different variables of a gas, like the volume, the pressure, the temperature. Starting in section 7.9, it's going to be very descriptive. Like, how do we describe the changes of state? How do we describe if it takes energy or releases energy when something changes from like a liquid to a solid or from a liquid to a gas? And then we're going to talk about a few specific phase changes. We're going to talk about evaporation of liquids. We're going to talk about vapor pressure, boiling and boiling point. And then a really big part of chapter 7, which we're going to be using in this class quite a bit moving forward, is section 7.13, intermolecular forces in liquids. So I know it seems like it's at the very end of the chapter and like maybe it's just this little extra tag on, but section 7.13 is actually going to be something that we refer back to quite a bit moving forward in the class. So don't skimp at the very end of chapter 7. Like I said, a lot of the sections are quite short, and then section 7.13 is has a little bit more to it. It's really cool. It explains a lot of what goes on in chemistry in terms of how molecules interact with each other. And we're going to be using it in chapter 8. So don't skimp at the end of chapter 7. So some cool things we're going to learn about in chapter 7. We're going to talk about popcorn popping. So towards the end of the first installment, when we get to the ideal gas law, hit pause, go grab some microwave popcorn and come back and eat popcorn while we talk about it. We're going to talk about how breathing works, what the gases are doing in your lungs. We're going to do a lot of example problems with inflating balloons. We're going to talk about how the properties of a gas like air change as you go up in elevation. We're going to talk about gases under pressure. So all sorts of things that connect to real life, which is one of the reasons I really like chapter 7. So the goals for this chapter as we get going, we want you to be able to describe the molecular basis for the different phases. So we want you to describe a solid, a liquid, or a gas using kinetic molecular theory. And that's what we'll talk about at the very beginning of chapter 7. We would like you to be able to quantitatively, so with numbers and calculations, determine the properties of gases using the gas laws. So we're going to cover Boyle's law, Charles's law, Avogadro's law, which is the one that's not explicitly stated in your textbook, but it's there because it relates to all the other ones. They just don't call it Avogadro's law, so we're going to properly name it and describe it. The combined gas law and the ideal gas law. And then to go along with those, Dalton's law of partial pressures. So that's the numbers part of chapter 7. Most of chapter 7 is descriptive, but in this section on the gas laws, you'll be doing some calculations. We want you to be able to explain how changes in state occur, like, for example, going from a liquid to a gas or from a solid to a liquid. And so we can explain these as being what are known as exothermic or endothermic processes. If they release heat when you do undergo a phase change, or if it takes heat, like absorbs heat, takes energy to undergo a phase change. So you'll be able to describe phase changes as being exothermic or endothermic processes. Do they take heat or do they give off heat? And then we'll be able to describe evaporation, vapor pressure, and boiling point in more detail. And then we want you to be able to describe the basis for the interactions between molecules. And these are what are known as intermolecular forces, the forces that cause whole molecules to be attracted to each other. So we've talked already about chemical bonding in this class. We talked about ionic bonds when electrons are transferred, and covalent bonds when electrons are shared. And so that's how atoms come together to make a bond within a molecule. Well, intermolecular forces describes what happens between one molecule containing a bunch of chemical bonds and a separate molecule containing its own chemical bonds. How do those two molecules as a whole get attracted to each other or potentially repel each other in solution? And this describes a lot of the basis for like physical things we see around, like why is a solution like viscous, kind of sticky, or why do some things boil at one temperature and another substance boils at a different temperature? And so intermolecular forces will help explain some of these physical phenomena that we observe in the real world using chemistry to explain them. So I think chapter 7 is awesome. I'm excited to be here with the class and to be getting into talking about taking all the chemistry we've learned about ionic and covalent bonds and the calculations we've done in chapter 6 and learning about electron configurations, and now getting to apply those concepts to more like real world stuff. So we're kind of entering the second half of the course. I consider the first half chapters 1 through 6. We're just learning about chemical bonds, learning how to talk about chemistry, learning nomenclature, learning how to do some essential chemical calculations. And now in chapters 7 through 12, we get to apply that knowledge to understanding how things that we observe in the real world, how they happen at the chemical level. So I hope you enjoyed chapter 7. I'll pause this video now. This was just an intro, and then the next one will be on section 7.1, kinetic molecular theory. All right, thanks. I'll see you then.